LIGO, short for the Laser Interferometer Gravitational-Wave Observatory, is a groundbreaking scientific project aimed at detecting and studying gravitational waves. Gravitational waves are ripples in the fabric of spacetime that propagate outward from massive objects undergoing extreme cosmic events, such as the collision of black holes or the merger of neutron stars. LIGO consists of a network of observatories designed to capture the faint signals of gravitational waves. The primary LIGO observatories are located in Livingston, Louisiana, and Hanford, Washington in the United States. Each observatory consists of an L-shaped interferometer with two perpendicular arms extending several kilometers in length. The functioning of LIGO relies on the principle of interferometry. A laser beam is split into two paths, with one beam traveling down each arm of the interferometer. The beams bounce back and forth between highly reflective mirrors located at the ends of the arms. When there are no gravitational waves passing through, the beams recombine and create a pattern of constructive and destructive interference, resulting in no measurable signal at the detector. However, when a gravitational wave passes through the observatory, it causes a minute stretching and squeezing of spacetime, altering the relative lengths of the arms. As a result, the recombined laser beams produce an interference pattern that can be detected. By precisely measuring the interference patterns, LIGO can identify the presence of gravitational waves and extract information about their source, such as the masses and spins of the objects involved in the cosmic event. This breakthrough technology has opened a new window for observing the universe, providing direct evidence for the existence of gravitational waves and revolutionizing our understanding of astrophysics and cosmology. LIGO made history in 2015 when it successfully detected gravitational waves for the first time, originating from the collision of two black holes. This remarkable achievement confirmed a major prediction of Einstein's general theory of relativity and marked the birth of gravitational wave astronomy. Since then, LIGO and its international partner observatories have made several significant detections, further expanding our knowledge of the universe and uncovering new insights into the nature of black holes, neutron stars, and other cosmic phenomena. Subscribe for more videos. Thanks for watching.